Because it's a multiplication problem, I'm going to go straight through here, and I'm going to say 7 times 15. So we'd have to take time to do 7 times 15. It's going to give me 105. We have to do 25 times 28, which is going to be 700. Now, those aren't numbers that normally you would just come up with right away. You'd probably have to work them out for most of us, and that would be extra time taken right there. So right away we see that a problem like this, if we're going to get larger numbers, causes a bit of an issue. So, now that we've multiplied these, we have to reduce this. So the question now is, what number goes into 105 that also goes into 700? 5 would be a pretty obvious choice, and that's probably where most people would start, so let's do that. So now we have to figure out how many times does 5 go into 105. Kiara? 21. Goes in 21 times. Then we have to figure out how many times 5 goes into 700. 140 times. This is getting a little ridiculous. These numbers are still not done. There is a number that goes into 21 that also goes into 140. Drew? 7. 7 goes into both of these. 7 will go into 21 3 times. It may not be completely obvious to everyone up front, but 7 also goes into 140, and it should go in 20 times, because 7 goes into 14 twice, with a 0 at the end. Now we have a final answer. There is nothing that goes into 3 that also goes into 20, so after all that, we are finally done. There was an easier way to do this. And this is the way that I'm going to want you to do this. So please pay very close attention, because this will save you a lot of time. If we started with the exact same problem, 7 over 25 times 15 over 28, some of you may be familiar already with the idea of cross-canceling or cross-reducing. To do this, look at the numbers in the numerators, look at the numbers in the denominators, and you want to find something that one numerator, doesn't matter which one, and one denominator, doesn't matter which one, have in common. As examples, 7 and 28 are both multiples of 7. So I'm going to cancel using a 7. 7 goes into itself once, 7 goes into 28 4 times. It's the same idea as reducing a fraction, except instead of being the numerator and denominator of the same fraction, they're different fractions, but that's okay. 15 and 25 are both multiples of 5. 5 goes into 15 3 times. 5 goes into 25 5 times. So now that I've cross-reduced everything, my new problem is 1/5 times 3/4. If I multiply these, 1 times 3 is 3, 5 times 4 is 20. It's the exact same answer, and I don't have to reduce anything at the end. So the benefit here is that I'm reducing with smaller numbers at the beginning. The largest number I had was 28. I can reduce with 28. And I avoid the idea of trying to reduce with numbers like 700. So you save yourself a lot of time by reducing at the beginning instead of at the end. Just please remember, it's a number from the top and a number from the bottom that get reduced.